Alright, so welcome back to the OneClass channel. Again, my name is Joey. I'm going to be your chemistry teacher for this session. So what we're doing at OneClass is we're going through this kind of session of verifying some frequently asked problems in both mathematics and chemistry, in both the secondary level as well as in the university and college level. So what we have today is I have a series of 10 questions in high school chemistry. So if you're looking at the Ontario curriculum, it's getting from grade 10 to grade 12, or if you're tuning in from the US, it's basically the junior level as well as the senior level chemistry courses. My name is Joey. I'm currently an Ontario school educator. My teachable subjects are chemistry, music, and soon to be mathematics after I finish up a teachable. So without further ado, let's get started on today's problems. Again, we have 10 problems per day, and we're going to go through these solutions together. So our first question goes, predict the ground state electron configuration of the following ions. It says write answers in abbreviated form. So this is concept of electron configuration. So what we have here is we have Ru2+, and we also have W3+ as well. So this is ruthenium, and W, I believe, is some type of metal. I'm not sure what W is actually. So maybe I'll have to look at my periodic table. But either way, what we have here is, W is tungsten actually. So that's over here. Okay, so we have ruthenium 2+ here. So ruthenium, we know here is, if you look at periodic table, it's in the metal section. And we know that ruthenium is atomic number 44, right? So what we can do is we can write the electron configuration for ruthenium first. So let's write ruthenium here. And it's going to be the electron configuration for ruthenium. So I'm going to go, again, I have the 1s2 electrons here. I also have 2s2, because 2s2 would be these two electrons. 2p6 is this block over here. The noble gases are cut off, but it's 2p6 here. 3s2 and 3p6 for both the third period. 3s2, 3p6. We have 4s2 here, signifying those two elements, and then this entire block here is a 3d10 block here. So this is the D block here. So this would be 3d10, and then we're gonna have 4p6 for these guys over here. So this is 4p6, and then 5s2 is these two electrons here, and then we're gonna make our way to ruthenium. So we have 5s2. And then we have 1, 2, 3, 4, 5, 6. So it's going to be 4D and then 6. And this is just ruthenium. So then it's asking us the ruthenium it has a charge of 2+ here. So it means my electrons here, I'm gonna remove 2 electrons from this 4d6 electron here. So I'm gonna erase this 6 on this guy here, and this will become, because right now it's a Ru atom here, I want a 2+, so therefore I need to remove 2 electrons, so I get a 2+ charge here. So 6 minus 2 here is going to be 4. So this here is going to be the electron configuration for ruthenium, and what we want to write here is we want the ground state actually. So we want the ground state here. So we all actually want Ru and not 2+ here. So this actually goes back to 6. So I didn't read the question, sorry. So this here is actually going to be a 6, because we want these in ground state. So therefore these are it's going to be a 46 on here. So that's okay. And what we can do is we can find the abbreviated form by taking the noble gas that we found here, and we can write the short form, the shorthand for electron configuration. So in this case here, ruthenium is here. So we're going to go back to the closest noble gas, which is krypton. So this can also be written as Kr. And then we can write out the electron configuration. So after Kr, we have, again, 5s2 and then 4d6. So 5s2 and then 4d and 6 here. So this is electron configuration for ruthenium, and as you can see, this here is correct. Yeah, this guy is good for the ground state. And what we can do with W here, this is the part B of this problem. This is W3 plus, right? This is tungsten. So what we can do with tungsten is we can actually do the exact same thing, right? So W, I know it's here, so we can go all the way back to the closest noble gas, which is if we go backwards here, I'm going towards the 5th period, and I can see xenon here is the closest one here, right? So I'm going to write xenon here. And then what I can do is I can write out the electron configuration here, right? So I have 6s2, which is these two guys here. And then it's going to go to this length, the 9th block, and this guy here is the F block, and this is the 4F block. It's 4F, and it's the F block, I believe, has 14 electrons as stated here, which is great. So 4F 14, and then we're gonna have this block here, which is 3D, 4D, and 5D. So it's 1, 2, 3. So 5D3 here. So this here is 5D3, which is great. And this is the electron configuration for the tungsten 3+. So this solution here is correct. So these two guys are the correct answer. And again, the solution is great. So the solution is correct. Good analysis here.